base, different exponents. When you are multiplying, what do you do to set exponents? Add them. Very good. When you have exponents raised to an exponent, multiply them. Good. What if it's to the 0 power? It's 1. Good. What if it's negative?
1 over 8.
Make it happy.
Which section was this?
All of this. 7.
What was one of these?
And if it's not happy in the denominator, it's happy in the numerator. And then really the only other one that we looked at was the play in war. When you had the same base, different exponents when you're dividing. I always said play war. And what that meant was, which exponent has a numerical value greater? Is it bigger in the top or is it bigger in the bottom? Whichever one of those wins is where it would stay. Okay? I thought that was much easier to write it out that way as opposed to when they define it as it would be a to the m minus n, then you might get a negative, then you have to move it around again. So why do all that work when you can just play war? Because fighting solves everything. Okay. So, going into what we're looking at today, what do you do if you have this? It's 2x. 2x. Okay. What if you have this? It's 2x. Okay. Let's talk about. I'll get there. Power functions and function operations. Ooh, sir. Let's talk about power functions and function operations then. So we're going to look at a lot of stuff in terms of function notation. F of x, g of x, h of x, things like that. I know that you guys have all seen this before. If I had two things like that, give you two functions. F of x is 2x minus 1, and g of x is x plus 4. I ask you then, what is f of 2? Do you remember what that meant to do? What did it mean? It means substitute. What do we substitute in? X for 2. But which equation? The one with the f in it, because what's that letter?
Q.
So what we did is we took the 2 times 2 minus 1. You get?
6.
3. Right?
Not 12.
Same thing that you would do with the g. G of 7 tells you to look at which equation? The one with the g. It's nice to know your alphabet from time to time. And g of 7 would be 11.
7. I think that's a great.
Now, yes, sir.
How come it's equal to 3?
2 times 2 is 4 minus 1 is.
I thought you meant something else.
It's been a year since you've done math. I understand.
Well, my eyes are not acted up the wrong.
Now, what about this? What if I did this? What would f of g of 2 mean?
G of 2 inside out.
Perfect. Everybody hear what he said there?
No.
Inside out.
Good.
Work on the innermost parentheses like you would in order of operations and build yourself out. Now it says g of 2. Well, that means you start at the g equation, you substitute in for 2. So you get 2 plus 4, 6. So g of 2 is 6, and then I take that and I use it as f of 6, which is then 2 times 6 minus 1, which gives you 11. This was a composite of a function that you probably didn't even realize that you were doing. Yes, sir.
All right, so what exactly does f of x and g of x like mean?
It's it's function notation. It's synonymous with saying y equals.
Okay.
Okay? It's an input-output. Y equals 2x minus 1. When x is 2, y is 3. When x is 2, f of x is 3. Means the same idea. Okay?
Okay, that makes sense.
You're going to see a lot more things written in terms of function notation as opposed to y equals this, y equals that, and so on. Because you think back, we had, even with quadratics, we said y equals x squared plus, or ax squared plus bx plus c. It's the same idea as saying y equals, or excuse me, f of x equals x squared, and so on and so on. Sir?
Wait, so do you substitute 7
For g of 7?
No, for the f of g of
F of g of 2. First thing you're going to do is figure out what g of 2
This
is,
makes sense.
and take that value and substitute it in for f. Inside out, just like you said.
Time out. Don't you multiply them though? Are they next
No.
to each other? You add them?
No. What this means is you would figure out whatever the g of x equation is first. Take that value, or whatever simplification might be, and you substitute in for x in the f equation. Our two functions were, was it f of x was 2x minus 1, oops, and then g of x was, thank you. So if I ask what is f of g of 3, I can change it up a little bit. Order of operations tells me to go to the innermost parentheses first. Well, that means find g of 3. G of 3 is, well, is 7. So then I have now, this simplifies to be 7. And then I go to the f equation with the 7.
I thought it was just like one, like if you solve for it, then that would be out.
Okay, there. Oh, you have no braces now. Oh, look what you did for a second there. Never mind, sorry. Oh no, look, at first when you smiled, it looked like they weren't there anymore. I'm sorry. I didn't mean to. So what we do then is we start with this easy. Then we worry about the exponents. Now, when I'm talking about this in terms of adding, subtracting, multiplying, dividing two functions together, it is nothing more than combining like terms. So to start with something simple, I have two functions. F of x is 2x, and g of x is x plus 1. And I'm going to add the two functions together to create a new one, subtract the two functions together to get a new one, multiply them, and divide them. When we create new functions, all it is combining like terms. So if I add these two together, f of x plus g of x, I just write that down as, well, 2x plus x plus 1. What's 2x plus x plus 1?
3x plus 1.
Good. Again, direct substitution. I do it again. Second time it asks me to subtract the two functions together. So I start with my f of x equation, which is 2x. And then I subtract the whole function of g of x. The whole function of g of x is x plus 1, so I have to remember, very good, This is the point at which most of you guys will forget. You have to distribute your negative. Hugely, hugely common. Just don't do it. It's like starting smoking, JC. Just don't do it. Yes, sir.
Especially not.
Would it be wrong to look at f of x and g of x as its own, like, term, I feel like that's the wrong word.
What do you think?
Alright, so you know how y equals something?
Yeah.
Can I look at g of x, like, would I be wrong to like?
Oh, you're trying to put two things together like a one graph type deal?
No, not graphs at all. Just like, would I be wrong to look at f of x as one term? That, yeah, perfect.
No, I see what you're saying. I see what you're saying here. What we're doing here is we're taking two functions and combining two functions.
Okay.
So you're right, it is its own term, and it is its own term, combine the terms.
So I think the f and the g's are still in there.
Oh.
If I just
Remember, what is f of x? Well, it's 2x. What is g of x? It's x plus 1. All these are doing is just saying, hey, rewrite me as a 2x. Rewrite me as an x plus 1. That's all that's saying.
okay.
Okay?
Okay, good.
Multiplication, same deal. It's just multiplying. You get 2x times. What do you get when you multiply those two together? Done. 2x squared plus 2x. Okay. And then the last one with the division, it's nothing more than just writing it as a fraction and seeing if you can simplify something. So when I use division here, I have 2x over x plus 1. Can I simplify that at all? No, I can't. But when I have a division problem, I have to be careful because there is a domain restriction. What can x be?
0.
1.
In this case, it can't be -1. You're on the right track. You can't be 0 in the denominator.
Oh, right.
When you're talking about 0 as a restriction, if I had 0 as my restriction, it would be okay because I get 0 divided by 1, which is 1. I haven't done math for a year.
Since last year.
Since
Since last
It hasn't been a year at times.
In my mind, it has been, honestly.
I know how you feel. to be honest.
So my answer here were x cannot equal -1. So whenever I have a division problem, I have to make sure I label my domain restriction. That's really the only tricky thing that can happen. Okay? Yes, sir.
Can you go back to the multiplication one? I did not.
Oh, all I did was I took f of x times g of x and distribute.
You mentioned this a little bit, but subtraction.
Oh.
You're stupid. How?
Oh, you're,
I
no.
was
I'm
looking above it.
I didn't have it spaced out completely. He's not stupid. You don't talk like
I
that.
know, I'm sorry. But I saw the same thing. I was going to ask you that, but I realized I was a stupid Is that you? That sounded like it came from behind me. That's crazy. He thought I did it, but it was you.
Thanks, Jonathan. Voice of reason. Does it change when you have fractional exponents? No. It won't change at all. When you have the fractional exponents, you still have to have the same ideas for combining like terms. You have to have the same base with the same exponent in order to combine like terms. It doesn't matter when you're multiplying, because if you're multiplying the same base with different exponents, you add them. So in this case here, if I wanted to add and subtract these two, I start with my f of x equation, which is 2x to the 1/2. Now, what's being raised to the 1/2 power? The 2, the x, both of them?
The x by itself.
Just the x. Just the x is being raised to the 1/2 power because you do not see that. I want everybody to make sure you understand that, okay? Since there's no grouping here, the only thing that's being raised to the 1/2 power is the x. Okay? The only thing that's being raised to the 1/2 power is the x.
So if it was a negative,
If it was a negative, if this was a -1/2, What's the only thing being raised to the negative 1/2? Yes. Right. So in this case here, we wind up, yeah.
How can you erase stuff off the board if the eraser's there and the sensor is like?
It also works for the palm of your hand.
Why doesn't any of they're all like
Only the Mac majors are really smartboard savvy.
Yeah, that's true. We've had them longer than anybody else. We've had them. What year is this?
I like how he looks at this watch.
We had it for about when did we had them for I think 2 or 3 years before we even came to this building. So we've had them for a while. We've had them longer than anybody else in the whole.
But like they don't even like know how to like turn it on. Like that's confusing to them.
What are you talking about?
Anyway, so you get here, you get 2x to the 1/2. What's 2x to the 1/2 plus negative 6x to the 1/2? Yep. And you're done.
You're adding and subtracting, the powers have to be equal, and then you're multiplying the bases.
Correct.
Okay.
And then the last one again, same deal. 2x to the 1/2 minus the negative 6x to the 1/2. And what did you get? Yes, sir.
How do you do half powers? Like I know it's an exponent, or it's a variable, but it goes a normal number.
Half power is the square root.
Oh, okay.
Half power is the square root. That again. All right, let's do multiplying and dividing then. So when I multiply functions, just like you were saying a second ago, the only thing that matters when you're multiplying is that you have to have the same base. What's the coefficient of the g of x function? 1. Just like we've done in the past, always take care of your numbers first. So this is a tough one. 3 times 1. 3. You was at 4.
No, I almost said 1.
Oh. Now you have same base, different exponents, you're multiplying, what do you do? What's going on? How you doing, buddy? I'm fine. Do you have like 5 seconds? Yeah, absolutely. Of course, we finally watched the Fargo 2 movie. Oh, what you loved it.
I know, it's so good.
That's
Christmas gift Yeah, she had special order from New Jersey. That's awesome. I know.
We took him to go watch it again the other night.
Yeah, so good. I actually thought he was in here today.
No, we did.
Yeah, so Mr. G is so
Bro,
cool.
I'm gonna have one of my husbands come up to the door in the middle of class and hey, you gotta say.
So,
Mr. G. So
same base, different exponents, you add. What's 1 plus a fourth?
1 and 1 and 1 and 1 4. Is that right?
5 fourths. Make sure you leave it with the improper fraction, okay?
Okay, I thought you just left it 3. I was confused.
Oh, we took care of it. 3 times 1 was 3. If this was a 2, if this was a 2, we'd get 6x to the 5 fourths. So,
Oh, okay.
you're just dealing with the coefficients like you would normally. All right. Now, if I go with the division, f of x divided by g of x, well, we had, what was it, 3x divided by x to the, I forgot, 1/4. You do the exact same thing. What's 3 divided by 1? 3. Very good. And then you have to play the game of war. Who wins? 1 or a fourth? 1. So what's 1 minus a fourth? 3 fourths.
Yay.
Okay. And that's how this stuff works. You're using the same properties, the same power, same rules as everything else. We're just doing it in terms of functions now. Okay?
Shut your mouth.
All right? Okay. Composites. Excuse me, composition, excuse me. Not composite, composition. When you're finding the composition of functions, this is that idea from earlier when we were writing things out of what is f of g of 2. Okay? We started with the g equation, substituted in the 2, and then surrounded that value with the f equation. Well, instead of writing it in terms with numbers, when we do composition of functions, it's going to be written like this. F of g of x, which basically means you're going to take the g of x equation and then substitute that in, or surround it, if you will, with the f equation. Let me show you a really, really easy example. F of x is x squared minus 1. G of x is 2x. And I want to do the composition f of g of x.
Can we find g separately from x? Like, all right, all right. I might be thinking it wrong, but I'm just like, all right. So g of x equals 2x.
Good.
Right?
Yes.
So.
Go on, say it. You're on the right track. I think I know where you're going.
Okay, so can you take the x from both sides and then make g equal to 2? Is that a possible thing?
No. Okay. All right. You started to say something that I thought you might have been going one way, but then you turned and went and they got lost. Yeah. You made a left turn at Albert.
My brain's stuck in 2015. I need to get my stuff off. That's why I keep asking so many
It's a Looney Tunes reference. Only 50s kids.
I got it.
Yeah, that's a real question.
Okay, can you explain?
So here's what I'm doing. When I have a composite function, one of the easiest ways to do this, or excuse me, composition of function, easiest thing to do is work your inside out, like you were saying a second ago. Write down what the g of x equation is. That is your innermost stuff. G of x is 2x. Now surround that with the f equation. Because what I'm doing here is that this says, take the g of x equation and substitute in for x in the f equation. That's what that says.
Oh, okay.
That's where I thought you were going, by
No,
writing
I
it
was
down in.
I forgot you wrote that. I was talking about just the g of x. I just wanted to make sure, like, I can solid think of g of x as one thing, and I can't separate g and x.
No, you can't.
Okay.
Okay.
Why isn't there the x? Like, why do you just do this square? Like, not an x squared?
Here,
Oh, because you're substituting. Got it.
I took this value of 2x, excuse me, and I substituted in for x here.
Got it. Okay.
So now what's the quantity 2x squared?
Will we ever have like the answer of f of x equals x squared minus 1 and then have to find out what g of x is?
Oh, you can do that.
That sounds
I
fine.
haven't thought about that. That's a great question. Maybe. What's the quantity 2x squared?
4x squared.
So this would equal then 4x squared minus 1.
This is making it.
I start with the innermost and build out of it. The nice trick to remember is if it tells you f of g of x, write down the innermost function and then surround it with the other function and simplify.
So we'd have writing 2x in the parentheses and then multiplying that by x squared minus 1.
We're not multiplying it. It's that would be a multiplication. It's a different setup. You can see the dot. Okay. This is substitution. Go the other direction. Let's try the other one. Let's say we want to do g of would g of f of x look like? What would g of f of x look like in this case? What would you start first?
2x in parentheses.
No.
Oh, right, you tricked me.
Start with the x squared minus 1. Oops. And then I surround it with 2. Not 2x because I'm taking.
That's x in the big.
Whoa!
You got me.
Wow!
And then you simplify it out.
Mr. Murphy, how easy, like, this is the part where someone says, wow, this is easy, and then it gets harder. Does this get any more complicated?
Oh, of course it does.
Okay.
Of course it
All
does.
math gets more complicated.
You could also do stuff like this. What is g of g of x?
Oh, okay. Like 2 times 2x.
Very good. Yes, ma'am.
Okay, so for the one above, why is it not, why is it just 2 and not 2x?
Because I substitute in for x the x squared minus 1. Remember, you're taking whatever's in here and you substitute in for x. Sorry, here.
Yeah, but x squared.
Take this, x squared minus 1, and you substitute in for x here.
All of that.
Okay? So g of x means start with the g of x equation and then surround it with what's left. The reason I'm surrounding with what's left because 2x is replacing just that value of x.
Wait, hold on.
And my answer would be 4x. Okay?
I don't understand why the g of f of x, why is the outside 2?
The g of f of x, remember, that means start by writing down the f of x equation, which is x squared minus 1. This value is being substituted in for x. So what's left in that g of x equation that's not x?
2. Oh, okay.
Now, notice if this happened to be 2x plus 7, I put in a plus 7 at the end.
Okay.
But since it's not, I don't have to do that.
All right, that makes sense.
It is quite literally substitute in 1 and then surround it. Right? Now you're worried about the other shoe dropping. It's when you have excellence to worry about. And
But like, if it was a plus 7, wouldn't that be like a value that you substitute? Why is it outside of it?
I'll show you here. Yes, ma'am.
Can you do G of the f of the gx?
G of g of x?
Yeah, like
Oh,
something
Yeah.
like that.
You just keep working your way out.
So you can do like G.
Yes. Yeah. Jeez. So I've got two functions. F of x is 3x to the negative 1, and g of x is 2x minus 1. What has the negative exponent in the f of x? Just x, nothing else. Just the value of x has the negative exponent. So if I want to do f of g of x, that means I start with writing down. Oh, sorry.
Will there always only be 2 functions?
And they might throw an f, g, and an h, and then you'll have like an f of h of x, and a g of f of x, and an h of f
So
of
the
x.
next would be 4 or 3?
It depends.
Okay.
Remember, this means start with the g of x equation, or excuse me, g of x portion, and then you surround it with the f equation. Well, the f equation has a 3 in front and the negative 1 to what's inside. Okay. Now, what's not happy besides you guys? The negative 1. Well, what's being raised to the negative 1? So you simplify this out, you get 3 over 2x minus 1. And now you're done.
Could you have just started
Oh.
3x plus 1 to raise it to 1? -1, I mean 3 over f.
Yeah, you can. And sometimes it's quicker just to leave it how it is because then you can, your exponents sometimes will cancel out and drop out and stuff like that. That's all. Okay. Same deal. G of f of x. What function do you write down first? 3x to the negative 1. So we start by writing down 3x to the negative 1. And then I surround that with the 2 minus 1. Now this is what you were talking about, or started a question about it a second ago now. The minus 1 is just tacked on afterwards. I still have to simplify the 3x to the negative 1. In this part here, what's not happening? Just the x. So when I multiply out, I get 6 over x minus 1. And I'm done. There's nothing else to do.
But the x was happening, so wouldn't the x go up?
It was already up to start with, and I dropped
I
it.
see what you're saying.
Okay. If there was something to simplify further, I might. Sometimes I can, sometimes I can't. It just depends on the function you're given. What's that? Is the 2 raised to the negative? Is the 3 raised to the negative? What's the only thing raised to the negative? X. Okay. Shimky.
Why don't you multiply the x by 2?
I did.
What? Oh, okay. That makes sense.
See what I did?
Yeah. Okay.
Last part. F of x. Which means start with the f of x equation. Let me bring this on the sheet here real quick. I have room. Start with the f of x. Surround it with a 3 and a negative 1. Distribute out your powers.
So the first power.
So you get 3 times 3 to the negative 1 times x to the positive 1.
Right.
3 1/3 times x, which is just x. You're using all of those exponent rules from last year. No, as in December. You didn't see that one coming?
This one. Oh, okay.
Okay. No.
Did you have to?
Do I have to do what?
Just no. Never mind.
I did the exponent rules. Since I got a monomial raised to the exponent, I distribute the exponent to both parts.
Oh, okay, that's
So I got the negative 1 to negative 1 is positive 1. I think I had another one like that. Yo!
Why isn't it just, oh, so that,
Why isn't it what? The 3 isn't negative, the exponent is negative. It's 3 to the negative 1, which just means it's not happy. Make it
Didn't
happy.
you say some rule about not using, like, I have such crazy rule where you don't distribute the to the number, they stay in half slot. I thought you said that, didn't you? I'm just, okay.
Is that 35?
Shall we?
be done.
Yeah.
Yeah, let's do it.
This is what, 7-3? I forgot when I typed that in there. I forgot to put in a couple multiplication parts. So, sorry, I added 2 problems. I'm sorry. I'll get over it. Tomorrow we'll talk about inverses. Inverses of functions use the property of substituting one for another all the time. That's how you're able to show that things are inverses. When you do that, you will get dun, 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 x every time.
Yay! Every single.
Also, one thing you will find out when you are working with inverses, it is a very, very fast thing to do. For example, if I wanted to find the inverse of the equation, no. If I want to find the inverse of y equals x minus 2, the inverse of that would be, well, exchange x and y and resolve for y. These two are inverses of one another. Because if you take one and you substitute in for the other, you're going to get x. It goes back. But we do it not just linearly, we'll do everything with fractional exponents. Yeah, real fast. 7-4 is inverses. 7-5, in lieu of time, I decided to not graph this stuff. I know you're heartbroken. It is something pretty simple. We will revisit it real fast when we start with second semester, just so you guys see it, because it does happen. It's another nice little spot for AH and K. It is a big thing. It hits in pre-calc, so we will spend a day or so on 7-5, the very first day of second semester, before we get into exponents. Or exponents. Yeah, we start doing exponents and logs and stuff like that. So that's a heavy graph section. All right. 7-6 is equations. Working with all these really weird fractional exponents and solving for equations. Again, working backwards. It takes no time at all. When I was saying about the whole review quizam thing Thursday, I'm going to write the quiz itself to be pretty short. That way it'll allow us to spend 10-12 minutes on any leftover questions from the equation work on 7-6 and leave you guys a good 30 minutes or so to take the quiz. I don't think it would, I'm making sure it doesn't take that long, but that way you don't get the heebie-jeebies on taking the quiz. Questions?
This was a successful math day. This was good.